Now for our second question, there are two lines and these are the equations which represent our lines, and a line L3 is parallel to L1 and passes through minus 5, 0. Now we can find L3 by using the point slope form. We already have the point, which is minus 5, 0, and we can also find the slope from L1 slope. We already have L1 and we can write, so L1 is this 6x plus 12y minus 72 is equal to 0, which tells us that 12y is equal to minus 6x plus 72, and that gives us y is equal to minus x by 2 plus 6. So the slope here is minus 1 by 2 because y is equal to mx plus c. So slope is minus 1 by 2. Now if we did point slope form on this, we would get y minus 0 by x plus 5 is equal to minus 1 by 2, which indicates 2y is equal to minus x minus 5. So therefore, x plus 2y plus 5 is equal to 0 is basically our line L3. And now if we looked further, we have line L4 which is passing through this point and it is perpendicular to L3. So if we took this to be M1 is equal to minus 1 by 2 is equal to M3, because M1 and M3 are the same slope, and let's consider the slope of L4 to be M4. So we can say M3 into M4 is equal to minus 1 because they are perpendicular. That would indicate M4 is equal to minus 1 divided by M3, which is basically 2. So we now have the slope of L4 and it also goes through this point. So again, using point slope form, we have y plus 5 by 2 by x is equal to 2. That would indicate y is equal to 2x minus 5 by 2. So this is our L4. Now the question that's being asked is, what is the cardinality of A, which is a set of all points common to at least two of the mentioned lines? For that, let's try to draw our lines on the graph. 6x plus 12y minus 72 is equal to 0 would give us, if x is equal to 0, it gives us y is equal to 6, which means some point, let's call this here, is 0, 6. It goes through this point, and if y is equal to 0, you get x is equal to 12. So that would be some point here. So our L1 is this line, and now we know L3 is parallel to this line. So L3, if we again did the same thing of putting y is equal to 0, x becomes minus 5, which is somewhere here. So as you can see, I am doing this on a rough estimate. I am not trying to be accurate, but even a rough estimate can work out here, because you might not always find graph paper when you require it. So often developing an intuition for the rough estimates is a good idea to solve problems. Now this is one point, and when x is equal to 0, y becomes minus 2.5, which is somewhere like this. So we have 0, minus 2.5. As you can probably see from our rough estimate itself, that these do appear to be parallel. They seem to be in the same direction. Now L2 if we look into it with a similar logic, we can see that L2 can be reduced to y by 6 minus x by 5 is equal to 1. So in our intercept form, we can now tell that if I made this plus, this becomes minus 5. So the x-intercept is minus 5, which is this point again, and y-intercept is 6. So that is this point. So L2 in fact passes through these 2 points. So this is our L2. So this was L1, now this is L3, and this is L2. Lastly, let's reduce our L4 into the intercept form. We get 4x minus 2y is equal to 5. Therefore, x by 5 by 4 plus y by minus 5 by 2 is equal to 1. So when we look at this, then 5 by 4 is a quantity just a little greater than 1, so it's probably somewhere here, and 5 by 2 is a 2.5 basically, so minus 2.5. So this and this, thus we have something like this happening. So overall there are 4 points which we see here, and on top of that L2 and L4 would intersect at a distant point somewhere over there. Furthermore, L1 and L3 are parallel, they don't intersect at all. So all put together we have 5 points in common. Now if R is a relation and it is the set of all points inside the region bounded by these 4 lines. So here when we say relation, we're basically saying every point in the set, when it's taken as a ordered pair like this, x comma y, then x would be from the domain of the relationship and y would be from the codomain. So this is seen as a relation from the set of x values and to the set of phi values. And now we are asked to find the range and domain of relation R, which is to basically find, when we say range, all the possible y values, and the domain is all the possible x values. So here in this region that we are looking at, the possible y values would be between this value and this value. So all possible y values are between minus 2.5 and 6, whereas the possible x values are between this point and this point, so that is between minus 5 to some particular quantity which is the x coordinate of this point, and that point is the intersection of L1 and L4. So let's try to solve L1 and L4 to find that point of intersection. You know that this is L1 and this is L4. From L4 we know that y is basically 2x minus 5 by 2. We substituted this into L1, we would get 6x plus 12 into 2x minus 5 by 2 minus 72 is equal to 0. This would give us 6x plus 24x minus 30 minus 72 is equal to 0. That indicates 30x is equal to 102, which indicates x is equal to 3.4. correspondingly y would then be 2 times 3.4 minus 2.5, because 5 by 2 is 2.5, which gives us 6.8 minus 2.5, which is equal to 4.3. So this point here is 3.4 comma 4.3, and we only require the x value. So the x values range from minus 5 to 3.4. However, one important thing we need to look for here now is the region bounded by these 4 lines, but excluding the lines themselves, which means minus 2.5 and 6 themselves don't fall into our domain, because we are not interested in the points on the curve. So this point is on the curve. This point is on the curve, but it's not inside. Similarly for each of these, because they are the border points. So minus 5 is not an x value inside the domain. Similarly, 3.4 is not a value inside the domain. So our domain is the open interval minus 5 to 3.4. Likewise, minus 2.5 is not a y value inside the range, and 6 is also not a y value inside the range. So our range is minus 2.5 to 6. Lastly, there is a line L5 presented by this equation. It's given to us. Find the cardinality of set B, which has all the points common to L1 and L5. Let's look at L1 and L5. L5 is given as x plus 2y is equal to 12. Now, if we applied our intercept form again, we would get x by 12 plus y by 6 is equal to 1. Let's look at that. X by 12 indicates x-intercept of 12. Y by 6 indicates y-intercept of 6. So we see that L5 is basically the same line as L1. Indeed, if you multiply this whole equation with 6, you will just get the form of L1. Therefore, L1 and L5 are the same lines. Then, the question is asking, find the cardinality of set B, which has all the points common to the lines L1 and L5. There are infinite points because they are the same line. So the cardinality of set B is infinite.